Alright everyone, welcome to this video that I'm going to show you probably one of the most useful features of conditional or logical operators within MATLAB, and that's the find function. You already saw me in class use it a couple of times, and now I'm going to explain exactly what it does. And we're going to do that with this pseudo or fake application to, I don't know, some thing. Let's say it's military. And in this applicants, we have 7 applicants that we're going to have in a vector called applicant number. Each one will get a specific code. And for some unknown reason, let's these applications to, I don't know, there's a height requirement for out of military or otherwise. And we have the heights of these students, these individuals in this matched program. So what if we want to know in this array the applicants that meet the minimum standard of 66, in this case we'll call these inches, in height, and we'll call this applicant number here. And so we want to know what the applicants are, who the applicants are, with the height of 66 inches or greater. So with this we can use the find command. So I'm actually just going to copy and paste this code and go directly into the scratchpad and just enter in that information. So we have our vectors in here. Now what can we do? Well, the find command, if we do find, it will return, and all it does is returns the index or the position of every part in an array that meets the criteria of the logical function. That's a really hard way of saying simply it tells us which position the vector is that's true. Alright, sorry about the jarring cut. MATLAB is crashing on me a bit, so here I'm back to where I was. Okay, going forward. If I just simply said height was greater than or equal to 66, what's it going to do? It's going to give me all the positions that it's true and false. So the first one is 0, false, true, false, true, 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 true. That's fine, I get all those, but that's just not really useful to me. I can't use that in any meaningful manner. If I said, however, find, and I said height is greater than or equal to, I'm going to say greater than or equal to 66, enter, it now has an answer value here, 2, 4, 5, 6, 7. I'm actually going to set that as a variable. Let's call that accepts is equal to find that. So now we have a variable of 2, 4, 5, 6, and 7. Those are the actual indexed positions of that vector that satisfies that requirement. How can I use that? Well, if I now say, well, which applicants are these? If I say applicants accepts, what's going to happen? I can say it's going to tell me, oops, the applicant accepts. It's going to tell me the numbers that fit that one. So it's applicant number 102, 104, 105, 106, 107. If I said applicants or height accepts, then I'll get the heights of these people at that same position. Now, that's actually quite convenient and quite easy for us to use. So, with that in mind, I can actually create a fprintf output that will tell us the position and the location of all of excuse me, of every applicant who does meet the requirements. So I can say in this fprintf command, I could say applicant number, I could say number, I'll even lose the little number key, and I will give the percent sign, let's do percent, let's do it here, percent 0.0.0f, Remember, I'm using the percent to identify where I want the number to go, and the positions, the number spacing I want for that, and so forth. Has a height of and I can give the height value here. Say I'm going to put another space holder for the height. In this case, I'm going to give a space holder of 2, because there's 2 numbers in there. This will be 3, and is accepted. And is accepted. And then I'm going to put a /n to make sure it gets that this line will be repeated. This is a carriage return, or enter at the end, so each line is repeated. And now I'm going to put in my vector that I'm pulling the data from, or the array. So I can say applicant accepts, and I will say height accepts. There you go, and that should be it. And there you go. And you can see here applicant number 102 has a height of 67 and is accepted. And you can go through the list like that and have that matched array. This is all there is to the find command that we have here, but we can do so much more with it. We can do so much more information, so many more clever approaches to it that I will give you other examples for in other videos. But I'm going to go back to a classic example to kind of give you a sense of just how robust you can have these find commands and get this information. So what do I mean by that? Well, let's go back to our die rolling example, how we can actually look at and create a vector of die rolls. So let's say we had a series of random numbers. I'm going to create throws for a 6-sided die, and here I can say random number generator of 1,000 throws, and I'm going to multiply this by 6, and I'm then going to do the ceiling of all that. So we should end up having in a random vector that if I say throws, it gives us a whole bunch of numbers just of 1, 2, 3, 4, 5, or 6, and that. But now, let's say I wanted to know just how many ones were thrown in that. How could I do that? Well, I could say ones, and if I do a find command, let's first do the find command. If I did a find command and I said throws are equal to 1, what's it going to do? It's going to be giving me all the numbers, all the positions of that array that equaled this value. So I could know exactly when we threw all the ones. However, if I said the length of the find of the throws is equal to 1, we can get that actual number. Now, some of you may pay attention that this can also be done with just adding up the ones and zeros, but there's a reason why you might not want to do that in the long run. We can always talk about that later in other examples, but this is a good example of how we can do this. So we can say ones is equal to the length of find throws is equal to 1. And we'll get the number of ones that happened there. And then I can say that for twos. I can say that for the threes. I can say that for fours. I can say that for fives. And we're last with sixes. And so now we just have a set of numbers of ones, that you can actually, the numbers are over here, so I won't belabor the point. But you can see ones, twos, threes, fours, fives, and sixes. So you get a sense now of just how often these different numbers were thrown. Now in since we throw in 1,000 different numbers, and if each number should come up the even number of times, then each number should have came up 167 times approximately. And sure enough, all the numbers seem to hover pretty close to this 167 value. Alright, so let's clear this out and give you one more example just to highlight what we can do with this. And let's say we have one more, we'll do an applicant pool again. Let's do applicants. And so we have applicants 101 to 110. We have those, and let's say we have age, and let's say the ages are going to be 18, 21, 40, 30, 35, 32, 24, 15. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have ages, and we have, let's go again to GPA. Let's say GPA is equal to, no, not GPA, let's just do height again. Height, and we'll say it's going to be 66, 62, 71, 72, 60, 58, 67, 64, 66, 68. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. That works. Excellent. So let me make sure that the vectors are all the same length. I think that's right. Okay, good. So we have a set of arrays. Now let's say, for example, our applicant pool, we just want the ones that are going to be over the age of 18, but less than 30, let's say, and a height of greater than 66. So if we have a complex set of values in that regard, what can we do? Well, we can still use the find command as we did before, and with the accepts, and in this case we can say accepts is equal to find, and in this case we're just going to have to use the more combined or complex coding that we had before. So in this case, the first question is, we want it to be find the age must be greater than or equal to 18, and it also has to be age is less than, I'm going to put spaces because that sometimes causes problems, age is less than or equal to 30, and we also want height to be greater than or equal to 66. So that's all. We'd have our entire requirements here that we said appropriately, hit enter, and we get the candidates by number or by the index of who they are. So we want to know the applicants at this value, applicants of accepts. Remember, this is an index that we're pulling from. We know it's now applicant number 101, 109, and 110. And that's it. And that's exactly how you can use the find command to get more complex information out of a data set and array. You'll notice these are the indices, and it is the raw value or position in that array. So if I was to, but if I had a 2D array, for example, let's say we have a new array of 5, 4, 3, 10, 21, 44, and 12, 12, 15. We have a position of arrays, and in this array, let's say we wanted to know the find of array that's greater than 10, say. And you'll notice we get the index position as for all those values as the absolute position. So it's going to count from 1, 2, 3, so that's greater than 10, 4, 5, 5 is greater than 10, 6 is greater than 10, 7, 8, and 9. So you see how those positions are. Now if you want, and so if I was to go back in and I said, in this case, array and go to answers, you're going to get all the values that match that. But let's say we don't want the absolute position or we don't want just a single row index, but let's say we wanted the row column format of that. Well, if we use the find command but ask for two variables, we could say row column as our variables, or we could say x comma y as our variables, is equal to find of array greater than 10, we would get a series of numbers that have matched arrays that now we can see the positioning of values in the array that match that. So third row, first column, 12 is the value. The next one is x is 2 and 2, so second row, second column is another value, and so forth. You'll note though, this is a little less useful than the actual row column, the single row array index that we had before. In this case, if I was just to say array and try to do x comma y, we're going to get a meaningless array because it's taking pretty much every position, all of these versus all of these in a 2D array. It's got all the numbers there, but it's just not the format that we would want to see the data in. In this case, we could say array of x in the first position, y in the first position, and we get one of the values. And then we could do the same thing for the second position and the second position, and we get that values. It's a little less useful, but sometimes if you would just like to know if a row or number is associated in a row column, we can use this as an approach. So this kind of summarizes the global view of find. Find is, like I said, one of the more useful features behind a lot of the logical functioning you can do in Excel or in MATLAB. But other approaches that can be used is if. And if and find do actually very similar things. And in the next video, I'll show you how you can use if to do some logic decisions that you can't use find with. So, well, thanks a lot.